Let us have a look at the conformational analysis of butane. You know that conformational analysis is the study of the energy variations happening to a molecule when there is rotation across CC single bond. Now we know that when molecules rotate across the CC single bond, we get infinite number of conformations. Okay. Now in this video, we shall discuss about the conformational analysis of butane. Now, butane is, is a 4-carbon molecule having the formula CH3, CH2, CH2, CH3. So this is the structural formula of butane. Now, if we write the Newman projection of this, you can put the two methyl groups in the eclipse position, all the bonds in the eclipse position, or in the all the bonds in the staggered position or an anti-position. Now these are the Newman projection of the eclipsed or syn conformation and that of the anti-conformation. Now to study the conformational analysis of butane, we can take the help of the ball and stick model of butane. Okay, now this is the ball and stick model of butane. You can see here butane has a CC central bond and then two terminal CC bonds. The central carbon atoms are attached to one methyl group and two hydrogen atoms. So on this central atom, the central carbon atom, you have one methyl group and two hydrogen atoms, and on this central carbon atom, you have one methyl group and two hydrogen atoms. So this is the ball and stick model, three-dimensional model of butane. Now to carry out the conformational analysis on butane, I shall take the help of ChemTube. For conformational analysis of ethane also, I have taken the help of ChemTube, a website. Now for butane also, we shall take up that. We shall look at how the conformations are formed when there is rotation across this central carbon-carbon single bond. So this is the structure of butane, three-dimensional structure, ball and stick model. See here, you can see when we rotate the molecule, all the bonds are clear now. Now, as I said earlier, this is from the channel chemtube3d.com, www.chemtube3d.com, not channel, I'm sorry, the website. Okay, now let us see how the butane molecule is, undergoes rotation and across the CC bond, and then how the molecules are, various conformations are formed. Alright, now you can see the molecule rotating, this CC bond is rotating, and this CC bond, the methyl group is changing. See, the position of the methyl group with the blue methyl group with respect to the green methyl group is changing when we are rotating the molecule across that CC bond. Okay, so see here. So you get infinite number of conformations when you carry out this rotation from 0 degree to 360 degree. Alright, now we shall see each rotation one by one. How does it happen, etc. Alright, let us rotate this molecule once more and yeah. Now, this is the new something like the eclipse conformation. Looks like the Newman projection of the eclipsed conformation. Okay, now we shall slowly rotate this and see how the Newman projection will appear. See, slowly the now if we say the dihedral angle between the two methyl groups is 0 degree now. So when we rotate this, see I'm rotating it anti-clockwise. So there is one conformer formed, a slight variation in dihedral angle, another conformer formed. So as we vary the dihedral angle, we get different conformations. Okay. Now at this position, you see here, this hydrogen atom and this green methyl group, they are anti to each other. Okay, so this is sort of a staggered conformation, the same way we have for ethane. But this conformation is not as stable as that of ethane because these two bulky methyl groups are near to each other. Okay, so this conformation is called gauche conformation, wherein the two bulky groups are near to each other, 60 degree apart. Now we have rotated it to 60 degree. So the bulky groups are 60 degree apart. All the bonds are anti to each other, but still they are not completely staggered. Okay, so this is called the gauche conformation. Alright, now we shall move it again. We shall rotate it again and let's see what happens again. So now we have arrived at another 60 degree rotation. Now you see all the bonds are eclipsed, but this is different from the first eclipse which we saw. Now in this case, what's happened? In this eclipsed form, or we can take this, this was what we have seen, In this eclipsed form, the methyl group is eclipsed by hydrogen atoms. The green one by this white one, and this blue methyl group is eclipsed by this hydrogen, and the two hydrogens are eclipsed. Now, so the two bulky groups are away from each other, so the energy will be less, but the energy will be a bit more than the next conformation which we will show. Okay, so this conformation will be having a lesser energy than the fully eclipsed conformation. Alright, and at the same time, this will be having a bit more energy than the gauche conformation. Now we shall again rotate this. It's rotating, and now you can see the two methyl groups have come opposite to each other, are placed anti to each other, 180 degree apart. They are placed at the farthest position. Now at this conformation is the most stable conformation of butane, wherein all the groups are anti to each other, particularly the two bulky groups are anti to each other or 180 degree apart. Now we again change the dihedral angle. See, we get various conformations, and now at this position we arrive at an eclipsed conformation again. Now we had seen another eclipse conformation earlier, similar one here. Now here, this eclipse conformation will be having a bit more energy than the anti-conformation, because there is this hydrogen and this methyl group are eclipsed, and also the bonds are eclipsed. There will be bond pair interaction. Alright, now we can rotate this again. Now we have come to another gauche position, gauche conformation. Now these two come together, so there will be steric strain over here, but then the bonds are anti to each other. Now we rotate this again, and we arrive at after 360 degree rotation, we arrive at the eclipsed conformation. So this is how the butane molecule will be rotating across the CC single bond. Okay, so you can see here the various conformations. This happens continuously. This rotation happens continuously. All right. So hope this rotation is clear to you how it is happening. So you can see here. Okay. Now we have to see the energy profile diagram of these conformations. All right. We shall see the energy profile diagram now. So these are the four conformations of N-butane. You have the anti and gauche conformation, which fall under the staggered conformations, and you have the two eclipsed conformations, out of which when the two methyl groups eclipse each other, then the conformation is called the syn conformation. Now when we look at the energy of these four conformations, we find that the anti-conformation is having the least energy and the syn conformation is having the maximum energy. Okay, so you can say that anti-conformation is the most stable and syn conformation is the least stable. The gauche and eclipsed come between anti and syn, and among eclipsed and gauche, eclipsed conformation is having more energy than gauche conformation. Okay, it's because in eclipsed conformation you have the methyl group and the hydrogen eclipse together, but in gauche the bonds are anti to each other. Okay, the problem over here, why we call this as gauche, is because the methyl groups, the bulky groups, are near to each other. Now we shall see what are the reasons why these molecules or these conformations differ in their energy. Now let us take the first conformation, that is the eclipsed conformation. Now in eclipsed conformation, the two methyl groups come together. Now you can see here, when the two methyl groups eclipse each other, then there will be van der Waals interaction between the two methyl groups, and you can see here the hydrogens attached to the methyl carbon on these two carbon atoms will interact, they will be overlapping. Okay, so the distance between the hydrogen atoms of the methyl groups in N-butane is less than the van der Waals radii of hydrogens. So these two will overlap, because of which there will be higher energy. They will be raised, the energy of the molecule will be raised. So that's one reason for high energy, the van der Waals repulsion. Secondly, there will be torsional strain or the bond pair interaction. Okay, so all the bonds are eclipsed over here, so all the bonds will be experiencing bond pair repulsion. Okay, so these two factors make the molecule highly unstable or raise the energy of the butane, eclipsed conformation of butane. So there will be steric strain, there will be van der Waals interaction, and also the torsional strain. Now, when you take, you can see here, the eclipsed is having highest conformation for butane. Okay, now that is when the dihedral angle is 0. Now the energy of eclipsed is almost 5 kilocalories more than the energy of the staggered. And staggered is having the minimum energy. The lowest energy conformation of N-butane is staggered. Now when you come to gauche conformation, now the dihedral angle between the methyl groups is 60 degree in gauche conformation. Alright, now in the gauche conformation, even though the bonds are anti to each other, that is, there will not be any much torsional strain, but steric strain is possible because these two methyl groups are placed near to each other. Okay, the distance between the two methyl groups here is almost 3.1 angstrom. In the eclipsed form, in the earlier case, that is in the syn form, the distance is 2.9 angstrom. So here it is 3.1 angstrom, not much difference. Okay, so they are quite close together. These two methyl groups are quite close together. So there is possibility of steric interaction and van der Waals repulsive force acting between the methyl groups in gauche conformation. Okay, so gauche is gauche is having higher energy than the anti-conformation. Okay, so this gauche interaction of butane, this interaction is called gauche interaction of butane, and this will be almost 0.9 kilocalories per mole higher than the staggered conformation. The energy of gauche conformation will be 0.9 kilocalories per mole higher than the staggered conformation. Okay, so the interaction between the adjacent between the methyl groups when they are 60 degree apart is called the gauche butane interaction. Now, when we plot the energy profile diagram for these various conformations of butane, the energy profile diagram looks somewhat like this, with 1, 2, 3 minima and 1, 2, 3, 4 maxima. Out of the 3 minima, one is having the least value, energy value. Now you can see here, the highest here when the dihedral angle is 0, that is the methyl groups are together, eclipsed each other, that is the syn conformer or conformation. Okay, so that's having the highest energy. Now almost 5 kilocalories per mole. Now, as we change the dihedral angle, as we increase the dihedral angle, what happens? The methyl groups move apart from each other. By the time we reach 60 degree, all the bonds would have reached anti to each other, and the methyl groups, angle between the methyl groups would be 60 degrees. So that's a gauche conformation. Okay, so they will be having a minimum energy than the syn conformation, because in syn there is torsional energy, strain, van der Waals strain, steric strain, but here we don't have the torsional strain. Now again, as we increase the dihedral angle, what happens? The methyl group moves closer to the hydrogen, so the bonds move closer to each other. So they reach an eclipse state at 120 degree when the dihedral angle between the two methyl groups are 120 degree. Again, another eclipse state is attained, and that will be 3.6 kilocalories per mole. The energy difference between the gauche and the eclipsed will be 3.6 kilocalories per mole. The energy difference between the anti and the eclipsed. Now, as you increase the dihedral angle, the methyl groups comes anti to each other, that is 180 degree apart, away from each other, the most stable conformation. Okay, and again, as you increase the dihedral angle, the molecule attains the eclipse conformation. Again, you increase it, lowers down the energy comes down, and as you increase the dihedral angle and reaches 360 degree, you reach again the syn conformation. So here we have got 3 conformers. Okay, that is 3 minima in the energy profile diagram. So the structure or the conformation corresponding to these 3 minima are called the conformers. So we have gauche conformer, 2 gauche conformer and 1 anti-conformer. While we have 4 maximas, 2 syn and 2 eclipse, they are of higher energy. Okay, and this 0.8 kilocalories per mole, that increase in energy between the gauche and anti is called the gauche butane interaction, because of the interaction between the methyl groups which are placed 60 degree apart. Okay, so this is the energy profile diagram of N-butane. So if we can summarize, we can say that in anti there is no torsional strain as the groups are staggered and the methyl groups are placed 180 degree apart. Okay, so no torsional strain, no van der Waals force of van der Waals repulsive force acting, no steric strain, nothing. So that's why it is in the minimum, having the minimum energy. In gauche, there will be van der Waals force between the two methyl groups, repulsive force acting between the two methyl groups. Okay, and also there will be steric strain is also possible. So it will be having higher energy than the anti. Now in the eclipsed, again there will be torsional strain and van der Waals repulsive force between the methyl group and the hydrogen. So they will be having higher energy than gauche and anti. And when you come to syn, that's the highest energy conformation of N-butane, wherein the torsional strain is high, the van der Waals repulsive force will be there, the steric strain will be there. Okay, so all these three factors makes syn conformer or syn conformation the least stable conformation. And it has been found that at room temperature, approximately 70% of the molecule of butane exists in the anti-conformation and 28% of the molecule exists in gauche conformation. Okay, there will be eclipsed conformation and syn conformation, but the rate of conversion of eclipse to gauche or syn to gauche is fast, so that the molecule will not be found more in that conformation. Alright, so this is the conformational analysis of butane. Hope it is clear to you. Please do refer other resources, and then if you have any clarifications, please do ask. Thank you.